All right, so let's go ahead and find a general formula for the sum of the first n perfect cubes today. So let's go ahead and start by defining a sequence a sub n, okay, consisting of all the cubes. So we have 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on and so forth. Okay, I think we can maybe stop there and indicate that that's going to be repeating infinitely. Now, we want to also establish a sequence of partial sums so we can hopefully describe a pattern developing here. Okay, so the first partial sum is obviously going to be 1, and then 1 plus 8, which is 9. 1 plus 8 plus 27, so 36. And then plus 64, so 100. 225. 441. 784, and so on and so forth. Okay. Okay. Well, we might actually be able to see what is happening already. I mean, this is 1 cubed, 3 cubed, 6 cubed, 10 cubed, 1 squared, 3 squared, 6 squared, 10 squared, 15 squared, so on and so forth. We want to be a little bit more precise in how we arrive at our general series formula. So let's find differences. Okay. So clearly, to get from to 9 from 1, we must add 8. To get to 36 from 9, we have to add 27, and clearly 64 here. This is not going to be a big mystery what we're doing here. Okay, so let's go ahead and populate those. Okay. So what about the difference of the difference? The difference of the differences, I should say. So to get to 27 from 8, we have to add 19. To get to 64 from 27, we have to add 37. To get to 125 from 64, we have to add 61. And to get to 216 from 125, we have to add 91. And to get to 343 from 216, we have to add 127. I had to think about that for just a second. Okay. Okay, so clearly we don't have a quadratic pattern here. All right. If we had a constant first difference, if you've watched these past videos in which I've derived these formulae, you'd know that if you had a constant first difference, you'd have a linear growth pattern, or shall I say arithmetic growth pattern. We are dealing with discrete math here, so I should probably use the correct term, arithmetic. If we have a constant second difference, it's more of a quadratic, discrete quadratic growth pattern. And here, maybe we'll have a constant third difference, in which case it'll be a cubic. I don't think it'll be a cubic, though. I think it's going to be a quartic. So that means we're going to have a constant fourth difference. But let's proceed and see where it leads us. So to get to 37 from 19, we're going to have to add 18. Okay, to get to 61 from 37, we have to add 24. To get to 91 from 61, we're going to have to add 30. And here we're going to have to add 36. Okay, so as predicted, we do not have that constant third difference there, but I do think we're going to have a constant fourth difference. To get to 24 from 18, we've got to add 6. To get to 30 from 24, we've got to also add 6. And to get to 36 from 30, we of course have to add 6. So a constant fourth difference, okay, if you've studied number theory or analysis even, okay, you will have been exposed to this topic. So a constant fourth difference means a quartic relationship. Okay, a quartic relationship. Okay, and we can go ahead and define our sequence of partial sums as a general quartic. So an to the fourth plus bn cubed plus cn squared plus dn plus e. Of course, let's not forget n is limited to being a positive natural number. Okay, now we have essentially 5 unknown variables, a, b, c, d, and e. N and s sub n will be replaced with the number of the partial sum and the partial sum respectively. Okay, so when n is 1, s sub n is 1, because 1 is the first partial sum. When n is 2, s sub n is 9, because 9 is the second partial sum. 3, 6, 4, 100, 5, 225, so on and so forth. Okay, let's go ahead and proceed in such a way. So we've got a 1 to the fourth plus b 1 cubed plus c 1 squared plus d 1 plus e equals 1. Okay. We've got a 2 to the fourth plus b 2 cubed plus c 2 squared plus d 2 plus e equals 9, right? Since 9 is the second partial sum. Okay, we got a 3 to the fourth plus b 3 cubed plus c 3 squared plus d 3 plus e equals 36, because 36 is the third partial sum. Now we're going to have a 4 to the fourth plus b 4 to the 3 plus c 4 to the 2 plus d times 4 plus e will be equal to 100, since 100 is the fourth partial sum. And we're going to need one more equation. Since we've got 5 unknowns, we're going to need 5 equations. So we've got a 5 to the fourth plus b5 cubed plus c5 squared plus d times 5 plus e equals 225. So we do have this big system here. And let's maybe zoom out. Probably end up zooming out a few times, I think. Upon the completion of this video, we will probably zoom out at least 5 or 6 times, but that's okay. So let's simplify this thing, and let's go ahead and proceed from there. So here we go. We have a plus b plus c plus d plus e is equal to 1. Okay. 2 to the power 4 is 16. So we've got 16a plus 8b plus 4c plus 2d plus e is equal to 9. Okay, 3 to the power 4 is 81. So we've got 81a plus 27b plus 9c plus 3d plus e is equal to 36. Okay, 4 to the power 4 is 256. So we have 256a plus 64b, okay, plus 16c plus 4d plus e is equal to 100. Okay, and then for the final equation here, we've got 625. Okay, 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625a plus 125b plus 25c plus 5d plus e equals 225. Okay, let's verify that we have committed no errors there. Don't believe we have, but let's confirm absolutely. Okay, looks good, yeah. Now, there are a number of ways you can try to solve such a system. Of course, we could use matrices. You could use the Gauss-Jordan elementary row operation technique. We could, of course, also use Cramer's rule, which would be pretty messy given that it's a 5 by 5, right? 5 equations, 5 unknowns. We could use substitution. I think probably substitution is the way I'm going to go here. We've got a bunch of e's that can be isolated. Okay, let's zoom out a step. And let's go ahead and solve everything for e, and then I can set e equal to e equal to e equal to e equal to e, thereby eliminating e and reducing a 5 by 5 system to a 4 by 4 system. And then I think we can probably do the same thing with d, since we see a pattern developing d, 2d, 3d, 4d, 5d. We can reduce it to a 3 by 3 and thereby to a 2 by 2, and that's, I think, how we can most expeditiously get through this. Okay, let's go ahead and solve everything for e. So here we go. We have, for the top equation, e is equal to 1 minus a minus b minus c minus d. Second equation, we've got e equals 9 minus 16a minus 8b minus 4c minus 2d. Third equation, e equals 36 minus 81a minus 27b minus 9c minus 3d. Fourth equation, we have e is equal to 100 minus 256a minus 64b minus 16c minus 4d. And then fifth and final equation here, we've got e equals 225 minus 625a minus 125b minus 25c minus 5d. Okay. I think we're good to go. Let's quickly give that a run through, making sure that we have committed no careless errors. Okay, second equation looks good. Third equation looks good. Fourth equation looks good. And then fifth equation also looks good. All right, so as promised, we're going to eliminate e entirely. We can set the top e equation equal to the second e equation, and that's going to give us the following: 1 minus a minus b minus c minus d is equal to 9 minus 16a minus 8b minus 4c minus 2d. Okay, we can set the second equal to the third. That's going to give us 9 minus 16a minus 8b minus 4c minus 2d is equal to 36 minus 81a minus 27b minus 9c minus 3d. Okay, let's zoom out again. Let's set the third equation equal to the fourth one. That's going to give us 36 minus 81a minus 27b minus 9c minus 3d equals 100 minus 256a minus 64b minus 16c minus 4d. And now let's set the fourth equal to the fifth. It's going to give us 100 minus 256a minus 64b minus 16c minus 4d is equal to 225 minus 625a minus 125b minus 25c minus 5d. Okay. Let's check that and make sure we have committed no careless errors. All right, first equation looks good. Second equation, good. Third equation looks good. And then fourth equation looks good. All right. Okay, well, let's now solve everything for D and try to do the same thing we did here. Okay, solving everything for D. We're going to have as follows. All right, adding 2D to both sides, we're going to have D on the left-hand side. And then subtracting 1 from both sides. Adding A to both sides. Adding B. And then adding C. Okay. Not too bad. Okay, second equation, let's add 3D to both sides. Yeah, this is going to work out really nicely, isn't it? Subtracting now 9 from both sides. Adding 16A to both sides. Okay. And then adding 8B to both sides. And then adding 4C to both sides. Okay. All right, third equation. Let's add 4D to both sides. Okay, and subtract 36 from both sides. Add 81A to both sides. I have to think about this one here. Adding 81A to both sides. It's going to give us minus 175A. Okay, good. And then adding 27B to both sides. It's going to give us negative 37B. Okay. Adding 9C to both sides. That's going to give us negative 7C. Okay. And then for the fourth equation, let's add 5D to both sides. Okay. And then subtracting 100 from both sides. You can see a pattern developing here, can't you? 2 cubed, 3 cubed, 4 cubed, 5 cubed. Okay, adding 256A to both sides. That's going to give us negative 369A. Definitely going to want to check this before moving on here. Adding 64B to both sides is going to give us negative 61B. And then adding 16C to both sides, that's going to give us negative 9C. Okay, let's definitely check that before moving on. Let's definitely not be too hasty here. Okay, so top equation. Let's check that carefully. Top equation looks good. Let's take a look at the second equation. Yes, yes, and yes, looks good. Okay, third equation. Yes, third equation looks good. I spent a lot of time thinking about that, but it looks good. And then, of course, the fourth equation. Let's carefully examine that one. Very carefully. Okay, negative 61b, and then negative 9c. Yeah, okay, everything's been examined. Looks good. Let's now set d equal to d equal to d equal to d. Okay, reducing a 4 by 4 to a 3 by 3. Isn't that convenient? All right, so setting the top equation equal to the second equation, we're going to have 8 minus 15a minus 7b minus 3c is equal to 27 minus 65a minus 19b minus 5c. Okay, second equal to third, we're going to have 27 minus 65a minus 19b minus 5c is equal to 64 minus 175a minus 37b minus 7c. And then, of course, setting the third equal to the fourth, we're going to have 64 minus 175a minus 37b minus 7c equals, it's going to be 125 minus 369a minus 61b minus 9c. Okay. Now let's solve everything for c. Well, we'll actually solve everything for 2c. All right, that's going to be the way to go here. Maybe zoom out one step. Whoops. Yeah, we'll just we'll just keep it like that. We're going to scroll down, and I'll zoom out when we have our final result. Okay, so we can see everything nice and clearly. Okay, so solving everything for c, 2c rather, adding 5c to both sides, we're going to have 2c here. Subtracting 8 from both sides, we're going to have 19. Adding 15a to both sides, we'll have negative 50a. Okay. Adding 7b to both sides is going to give us negative 12b. Okay. All right, second equation. Let's add 7c to both sides. It's going to give us 2c again. Subtracting 27 from both sides, that's going to give us 37. Adding 65 to both sides, that's going to give us negative 110a. And then adding 19b to both sides, that's going to give us a negative 18b. Okay, bottom equation, let's add 9c to both sides. Again, that nice 2c. We can do exactly what we did with these, reducing a 3 by 3 to a 2 by 2. Won't that be fun? Okay, subtracting 64 from both sides, we're going to get 61. Adding 175 to both sides. Okay, it's going to give us negative 194a. Okay. Adding 37b to both sides, that's going to give us negative 24b. Okay, let's definitely check that before we move on. Let's check the top equation. Okay, that looks very good to me. Very good. Let's check the middle equation. All right, I'm glad we checked. This should be 27, not 37. That's why we check. That is why we check. Oh, wait, no, it should be. Never mind, that should be 37. Yes. That's why we check what we check. How about that? All right, and what about the rest? Adding 65a, negative 8. Yeah, everything looks good in the middle equation. Let's check now that bottom equation. Okay, should be 61, negative 369a plus 175a, negative 194b. 94A, that is correct. And then, of course, negative 61B plus 37B, negative 24B. Yeah, we're good to go. We are good to go. Okay, now I can set this equal to this, and I can set this equal to this, and that's going to give us a 2 by 2. So we'll have 19 minus 50A minus 12B equals 37 minus 110A minus 18B. Okay, and then we're going to have here 37 minus 110A minus 18B is equal to 61 minus 194A minus 24B. Okay. Let's check to make sure we wrote everything down correctly there. Indeed, we did. Okay. Well, I can solve for 6B bottom and top, can't I? Yes, adding 18B to both sides, I'm going to get 6B over here. Subtracting 19 from both sides, I'll get 18 here. Adding 50A to both sides, I'm going to get minus 60A here. Okay, good. Now for the bottom equation, adding 24B to both sides, I'll get 6B over here. Subtracting 37 from both sides, 24. Adding 110A to both sides, negative 84A. All right, let's check that carefully. I will zoom out at this point one step. We are very close to solving this. We just want to make sure we have no careless errors on the page. So let's be careful in our examination here. Top equation looks good. And what about the bottom equation? Does that also look good? It does. Okay. Well, we can clearly use elimination method here. Those are going to cancel out. I'm going to get 0 on this side. 18 minus 24 is negative 6. Negative 60A minus negative 84A is the same thing as negative 60A plus 84A, and that's just 24A. Okay. Well, we can see clearly that A equals 1/4. Okay, we add 6 to both sides and divide both sides by 24. Okay, well, knowing that A is equal to 1/4, we can now find what B is. Let's plug in A equals 1/4 into this top equation and find B. So we got 6B equals 18 minus 60 times 1/4. So that's equals 18 minus 15. 60 divided by 4 is 15, and that's of course 3. So that means that B, dividing both sides by 6, is equal to 1/2. Okay, that's convenient. We found A, we found B. Let's now seek to find C. Let's just use this top equation here. We've got 2C is equal to 19 minus 50 times A, which is 1/4. Okay, minus 12 times B, which is 1/2. Okay, making sure we've plugged that in correctly. Indeed we have. So it's going to give us 19 minus, we'll simplify this to 25 over 2. And this we're going to keep it as 12 over 2, since we're going to want to find a common denominator here. So this is going to be 38 minus 25 minus 12 over 2. Well, 38 minus 25 is 13. 13 minus 12 is 1. So this is 1 over 2. So that means C equals 1/4. Convenient. Okay, so we found A, we found B, we found C. Let's now find D. Again, using the path of, taking the path of least resistance, we'll use this top equation here. So we've got D is equal to 8 minus 15 and then times A. Okay, minus 7 times B, and then minus 3 times C. Okay, let's make sure we plugged everything in there correctly. Indeed, we did. Okay, well, common denominator here is going to be 4, so it's just going to give us 32 minus 15 minus 14 minus 3 over 4. Okay, so checking that. Yeah, good. So 32 minus 15 is 17. 17 minus 14 is 3, and 3 minus 3 is 0, so D equals 0. Okay. And then to find E, we can just we can go ahead and use this top equation here. So we're going to have A, okay, plus B plus C plus D plus E equals 1. Okay, well, 1/4 plus 1/4 plus 1/2 is 1. So E is therefore going to be equal to 0. Okay, we found everything, didn't we? We did. Well, we got this big space up here, so let's just go ahead and use it. S sub n is equal to, well, here it is. What's our value for A? It's 1/4, so we have 1/4 n to the power of 4 plus B, which is 1/2, so 1/2 to the n to the power of 3 plus C, 1/4, so 1/4 n squared. And then D and E are both 0, so we can effectively stop right there. Now I can take an n squared over 4 out, okay, and I'm going to have left in here n squared plus 2n plus 1, okay? Let's check that. Yes, indeed, that is correct. And this can be factored as n plus 1 quantity squared. So this whole thing becomes, as you'll maybe recognize if you've studied calculus and you've seen these summation formulas here, okay, here it is. This is the formula for the sum of the first n perfect cubes. Glad we were able to fit that all into one page there. Hopefully you like this video. It took us a little while to get there, but we got there. We persisted, and that's how you get good at math, quite frankly, is you persist and you have to like it. Let me know if you have any questions, comments, concerns. Of course, we're always open to recommendations for future content. Have a great rest of your day, and we'll see you in the next video.